So what are dBs? dB stands for decibel. A decibel is a logarithmic ratio between powers, and its formula is given by 10 log of P2 divided by P1. So the voltage formula for calculating decimal value is slightly different. Instead of 10 log, we have 20 log of the ratio. Here is why. The normal formula tells us that we have to take 10 log of P2 over P1. We know that the relationship between power and voltage is a square one. P is equal to V square over R. When we put this in this equation, we're going to get 10 log of V2 squared divided by R under V1 square divided by R. The R's will cancel out, and what we will be left with is 10 log of V2 divided by V1 whole squared. Now we know that the logarithmic law, which is log x to the power a, is actually equal to a times log of x. Applying this law here, we get 2 times into 10 log of V2 over V1, which is equal to 20 log of V2 to V1. So this is how we get the formula for calculating decibel value when the ratio is of voltages. So let's suppose we want to find the decibel value of some number. For example, let the number be 2. So let's find the decibel value for the number 2. Using the formula, we have 10 log of 2 here. The second part we take reference as 1, and we have 10 log of 2, which comes out to be, we put in the calculator and we get the value 3. So 2 in linear scale is actually equal to 3 decibels in the decibel scale. Now to show the relationship, real relationship with respect to calculations, we see that the multiplication by 2 in linear scale is actually equal to plus 3 decibels in decibel scale, and similarly, and division by 2 in linear scale is equal to minus 3 decibel in decibel scale. For example, we have a value 10. Now what is this actually saying? It's saying that we have a number 10. When you take decibel value, it comes out to be 10 decibels. Now in linear scale, if you divide this number by 2, that is 10 divided by 2, you get 5. But on the other hand, when we consider the decibel scale, this same number which was 10 decibel, we won't be dividing anything with it. We will minus 3 decibel from it, and we'll get 7 decibels. And from here we can see that 5 is actually equal to 7 decibels. Same goes for the multiplication part. In the formula 10 log of P2 divided by P1, this P1 value here is actually the reference value. And how that goes, you can see that if the reference is taken as 1 watt, if the power is 10 watts and the reference is taken as 1 watt, then this value will come out to be 10 dB watts. Whereas if the power, that is, the reference is taken as 10 milliwatts and the P2 which is being charged as 10 milliwatts and the reference is 1 milliwatt, then this value will be 10 dBm. If the reference is basically taken as 1 milliwatt, then the decibel value calculated is actually in the unit of 10 dBm, whereas if the reference is 1 watt, the unit comes out to be 10 dB watt. What does this mean? For example, if we have 10 dBm, 10 dBm value of power means that the power actual value is 10 milliwatts, whereas 10 dB watt of decibel power means that the power that you have is 10 watts in linear scale. Alright, now comes the favorite example. Suppose we have a value of 10 dBm and we're going to subtract 7 dBm from it. Now if our purpose is to find the ratio between the two values, then it's okay, and the value comes out to be 3 decibels. But if, for example, input power is 10 dBm and the output power comes out to be 7 dBm, and we have to see how much power was lost. So the output is not actually, we don't require a ratio, we want the power to be the output, then the value comes out to be 7 dBm. Now this is totally mind-boggling, because 10 minus 7 equals 7. All maths gone wrong. Well, not quite. Why? Because the subtraction is happening in the decibel scale, and we learned before that in the subtraction in decimal scale is equivalent to division in the linear scale. We don't want to divide these numbers. For example, if we have a case in which input power is 10 dBm and the output power is 7 dBm, we actually want to take the difference between the powers in the linear scale. Alright, so what we're going to have to do is we'll have to convert these values 10 dBm and 7 dBm in the linear scale, and then we subtract the actual values of power there, and that would actually be the difference of two powers which is actually required. Difference in the decimal scale will give us the ratio. We don't want the ratio, we want the difference. So 10 dBm is 10 milliwatts, whereas 7 dBm is 5 milliwatts, and that's now turns out to be 5 milliwatts. And this 5 milliwatts is actually 7 dBm in decibel scale.